So for number 3, we have soluble molecular compounds. So they dissolve to form molecular solutions. They have intermolecular forces of London dipole, 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 and hydrogen bonds are broken. Okay, so for example, here we have sucrose, okay, which just then forms an aqueous solution. We have acids. So these are molecular compounds, but they are very polar. And they dissolve to form ions in solutions, so they ionize, and they turn litmus paper red, okay? And we need to balance the number of ions. So for example, we have H2SO4, which is a solid, and it breaks down to its hydrogen ions and its SO4 ions, okay? So, for examples here, we write the equations to show what happens to each of the following in water. So we have potassium chloride, okay? Potassium chloride, it's ionic and it's going to break down into potassium and the chloride ions. Carbon dioxide, okay? Carbon dioxide does dissolve in water and it just forms an aqueous solution. Solid hydrogen nitride, okay? This forms the hydrogen ions and the nitrate ions. Aluminum sulfate, okay? It's a solid, breaks down into aluminum and the sulfate ions. And we need to balance these again, so this is very important that we're balancing. Then we have sodium phosphate decahydrate, okay? Sodium, the phosphate ions, okay? And we're balancing these again. Gasoline, okay? As a liquid, stays as a liquid. This is one that does not dissolve. Barium sulfate, again, does not dissolve, and we can get that from a solubility table. Now, many chemical reactions, either in our bodies or in the lab, are very slow if the reactants are not dissolved in water. Dissolving in water allows the solute particles to separate, disperse, and collide with other solute particles. So particle collisions are necessary for reactions to occur. Alright? So we're going to talk in the next video about molar concentration of ions.